Good morning, boys and girls. Okay, we'll continue lesson 5. Okay, we are on units of heat. Okay, so the most common unit is calorie. Now, how much is 1 calorie? 1 calorie is the heat required, amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. Okay, so 1 calorie is equal to the amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. Suppose the temperature is somewhere the temperature of water of 1 gram of water is 15 degrees Celsius, and we start supplying heat, and it goes to 15 to 16 degrees. So now the temperature has changed from 15 to 16. So the heat it has absorbed is 1 calorie. Okay. Now kilocalorie is just the higher unit of calorie. Kilocalorie means if 1 kilogram of water rises by 1 degree, okay, so the amount of heat supplied to it is 1 kilocalorie. Okay, it's just the higher unit of calorie, and 1 kilocalorie equals to 1000 calorie. Okay, but the SI unit of heat is joule. Okay, and the unit of work done is also joule. Okay, so we know in work done also we need energy, and heat is also form of energy, so they have the same unit here. Okay, so now it's just a conversion. How much is 1 joule in terms of calorie? So it's 1 calorie equals to 4.186 joule. Okay, so we can convert a calorie into joule. Okay, now scales. Okay, thermometric scales. So what are the scales in which we measure temperature? So there are 3 scales used, and all 3 are used till now. Okay, the earlier or the English system, Fahrenheit was used and is still used, but most common is Celsius, and the SI is Kelvin. Okay, so uh, Fahrenheit is what in terms of water will see. Okay, we'll check it. So water, the freezing point of water is 32 degree Fahrenheit. Okay, and the boiling point of water is 212 Fahrenheit. Now we divide into this from this to this into 180 equal degrees. Okay, so this becomes our scale from 32 to 212. It goes above that also and below it also, but that is the division we can understand. Okay, so from this to this there are 180 divisions, and it goes below and above also, of course. Okay, so this is used, still used Fahrenheit. You know, in medical sciences also, we in India also we use this one also. commonly this more than the Celsius scale. Okay, now Celsius scale it is again we take a freezing point of water as 0 and the boiling point as 100 degrees Celsius. Now there are 100 divisions between these two, and that is 1 unit when we divide by 100, and it goes above and below also that. Okay, and that is Celsius scale. Now the Kelvin scale. Kelvin is Kelvin is the absolute zero we take as 0. Okay, okay, in Kelvin we start where the minimum temperature can go. So we have taken that point as 0. Okay, so it cannot go below that the temperature of any body or any substance. So it is found, we assume that as 0, and from there we go above. Okay, 1, 2, 3, and 4 like that. So we start from there, that is taken as absolute 0, and then it goes on. The unit, the division is equal to the Celsius division only. So it's very simple to convert from Kelvin to Celsius or Celsius to Kelvin. Now we look at the conversion here. Okay, it's in the absolute 0 or 0 Kelvin is taken as 273.15 Kelvin. Okay, no, minus 273.15. Okay, in generally we don't take 0.515. Okay, just to understand better we take 273 only. Okay, so the absolute 0 is in terms of Celsius minus 273 Kelvin. Okay, now the conversion here, how these scales are converted to another scale. Okay, when we convert Celsius to Fahrenheit, we have a formula here. Okay, by using this formula, we can convert Celsius to Fahrenheit. The 9 upon 5 into Celsius. So whatever Celsius is there, we just multiply here and simplify it and add 32, and you can get your Fahrenheit. Now Fahrenheit to Celsius, this formula. Okay, here just write the value of Fahrenheit, subtract 32 and multiply, you will get Celsius. Celsius to Kelvin. Okay, just don't take this 0.15, then it's become simple. Just we have to add 273 in the Celsius scale, so you can get Kelvin. Kelvin to Celsius, we just subtract this 273. Okay, Fahrenheit to Kelvin is this formula. Kelvin to Fahrenheit is this. Okay, so you can understand this formula, or you don't need this formula. If you know how to convert Fahrenheit to Celsius, then Celsius to Kelvin you can convert here. So we don't need this formula actually. Okay. Now you can look at the figure here. Okay, here the comparison of all three scales. This is Fahrenheit, Celsius, and this is Kelvin. Okay, now uh, 0 Kelvin, the absolute 0, this is the Kelvin scale, is equal to minus 273 Celsius, and in Fahrenheit this is minus 459 degrees. Okay, same way the boiling point of water which is, we know in Celsius it is 100 degrees Celsius, in Kelvin 373, and in Fahrenheit 212. Okay, now what are the effects of heat? Okay, effects of heat: change in temperature. We know when we supply heat to a body, in any form, okay, solid, liquid, or gas, the temperature rises. Okay, it becomes hotter and the temperature rises. Change in dimensions. Okay, when we supply heat to a body, it expands. Okay, expands means in all three dimensions. It expands: length, breadth, and height. Or we can say the area increases and the volume also increases. Okay, and when uh, it cools or the heat is taken away, it contracts. Okay, now change in state. By supplying heat, we can change the state also. When ice is heated or ice gains heat, it changes to liquid. You have seen that. Okay, same way when we heat water and it comes to boiling point, it starts changing to gaseous state, that is vapors. Okay, now chemical change. For different chemical reactions we need heat. Okay, so heat can make a chemical change of the substances. When we burn coal or wood, it changes to ash, giving heat. Okay, that is exothermic. Okay, now we take some reactions. Okay, like here is an example given: potassium chlorate on heating, it decomposes, okay, to form potassium chloride and oxygen. So there are many chemical reactions like that which require heat to take chemical reaction. Okay, so chemical change can be there if heat is supplied. Often now, effects on living beings. Okay, all living beings have a fixed temperature, like human have 98.6 degree Fahrenheit or 37 degrees Celsius. Now, if you have more than that temperature, we call it as fever. That means we are not healthy. Same way, if it goes below that, so it affects living beings. Okay, same way all other creatures also, living beings. So these are the effects of heat. Okay, now good and bad conductors, will come to it later on. But okay, now you go through whatever these here factors. Now the definitions, okay, you should know. The conversion you should know. Okay, and these scales and this formula. Okay, go through it carefully. This is okay, quite important, and the effects of heat. Okay, then in the next class we'll see good and bad conductors, their examples. Okay, and then methods of heat transfer. Okay, So you better go through this also, so it will be easy to understand. Okay. Okay, then in the next class I will try to finish this chapter.